Okay, so got a toboggan going down a curve. For some reason we know the equation of that curve is y equals 0.01 x squared. I want to find the magnitude of the acceleration at point A. Okay, I know the speed is 10 meters per second and the rate of increasing speed is 3. Okay, so my total acceleration is going to be the tangential acceleration plus the normal acceleration. Okay, and my tangential acceleration is given to me as 3, given in the problem statement right there. Okay, my normal acceleration is going to be v squared over rho, where my velocity is 10, and of course I don't know rho, so I need to calculate rho using the equation from calculus that helps me find the radius of curvature of any point on the curve. And fortunately, I know the equation for the curve that I'm on. So this is dy dx squared to the 3/2 all over the second derivative of y with respect to x, absolute value of that. So what I know here, let's go ahead and say, okay, let's take my derivative dy dx. That's just going to be very simply 0.02x. Plugging in that x is 60 here, okay, because I want to find the radius of curvature specifically when x equals 60, then this becomes 1.2. The second derivative, okay, is just going to be 0.2, and that's, or 0.02, excuse me, and that's going to remain constant, right? That x drops off, so that's just going to be constant, okay? So I'm going to plug these up into my rho equation to find my radius of curvature, and I'm going to get 1 plus 1.2 squared, all of that to the 3/2 power, divided by the absolute value of 0.02. And from that, I get a rho of 191. That would be meters at this point. So from this, I can plug in and find my normal acceleration, which would be 10 squared divided by 191. And from that, I get my normal acceleration equal to 0.525. So I can then find my magnitude of my acceleration as 3 squared plus 0.525 squared. And from that, I can find the acceleration of 3.05 meters per second squared. So again, break it up into its components. I know my tangential acceleration. My normal acceleration is v squared over rho. I know v. I just have to find rho using some calculus, find rho at the point that I'm interested in. And then from that, I can find my total acceleration.